everyone, my name is Nancy and I'm currently a high school student. In today's lesson, which is lesson number 2 out of a series of lessons where we introduce you to an incredible competition, which is a national science competition here in Greece, the Hellenic Young Naturalists Tournament, we will be watching and decomposing the second Hellenic Young Naturalists Tournament, and most specifically, one stage that occurred in its finals. So hopefully it will be helpful. But let's get to know the teams. Since we will be seeing an actual fight, these teams are actual teams of actual people, of actual schools, things like that. We don't really care about who's who and what team is what, so we will be naming the teams as if they were colors. So for example, we'll be having 3 teams, since every single stage has 3 teams competing in it. So we have the blue team, we have the purple team, and we have the green team. The blue team in the particular stage that we will be seeing is going to be the reporter, meaning the one that's going to present their solution to a certain problem. So the purple team, on the other hand, is going to be the opponent, meaning the one who's going to oppose, to criticize and evaluate the solution to the problem that the reporter, meaning the blue team, is going to present. And finally, we have the green team, which in this particular fight is going to be the reviewer, meaning the one that evaluates both of them. You see that in every single team, there are either 5, 3, or 4 people. But when a team is either the reporter, the opponent, or the reviewer, there's actually only one person representing the team each time. So for example, right now that the blue team is the reporter, this girl is going to represent her team and present the solution to the problem, but the rest of the girls are not going to be on stage. The same goes for the opponent team and the reviewer team. So here you can see that the opponent is going to be this boy and the reviewer is going to be this girl. In the previous lesson, we saw the interactions between the reporter, the opponent, and the reviewer, but let me remind you what a stage looks like. Firstly, we have the challenge by the opponent, then we have the acceptance or rejection of the problem by the reporter, then we have the preparation of the reporter, the presentation of the report, clarifying questions of the opponent to the reporter, preparation of the opponent, statement by the opponent, discussion between the opponent and the reporter, clarifying questions by the reviewer, preparation of the reviewer, statement by the reviewer, concluding remarks by the opponent, concluding remarks by the reporter, and clarifying questions of the jury. Something that we did not mention in the previous lesson is that in the semifinals and in the finals, you are the one to choose what problem you present as a reporter. So there's no challenging, there's no accepting, there's no rejecting. So the first 2 steps simply vanish. So this girl is now going to prepare herself. Let's see that.
Hello everyone, my name is and today I will be presenting you the problem number 11, which is oxygen from plants. So the task here is to suggest an experimental method to measure how much oxygen is produced by a green plant. These are my contents. To begin with my introduction about the procedure of photosynthesis. Photosynthesis is the process by which plants use sunlight, water, and carbon dioxide to create oxygen and energy in the form of sugar, as you can see in the picture here. Continuing on, during photosynthesis, plants take in carbon dioxide and water from the air and soil. Within the plant cell, the water is oxidized, meaning it loses electrons, while the carbon dioxide is reduced, meaning it gains electrons. This transforms the water into oxygen and the carbon dioxide into glucose. The plant then releases the oxygen back into the air. Okay, some theory about wavelength. The greatest amount of sunlight is emitted at wavelengths around 500 nanometers. That's why it appears yellow. This is the reason why in an experiment with a yellow light we expect the best oxygen production. The greatest amount of red light is emitted at wavelengths around 650 and 700 nanometers. The greatest amount of blue light is emitted at wavelengths around 400 to 450 nanometers. So here are my parameters. The dependent ones, meaning the ones that we measured throughout our experimental procedure, was the oxygen production rate and the oxygen quantity. The independent ones, meaning the ones that we changed throughout our experimental procedure, was the lamp color. The control ones, meaning the ones that we kept the same throughout the experiment, was the humidity that we tested, the temperature that we kept, that we controlled with an Arduino sensor, the type of plant, and the lamp distance. So here are my 5 hypotheses. The first one is that with the yellow light we will have the fastest rate of oxygen production and the largest amount of oxygen quantity. This is because the yellow is the color of sunlight. The second one is that the red lab setup will produce more oxygen than the green lab setup because red is a warm color, whereas green is a cool color. Third one is that the red lab experiment will produce more oxygen than the blue lab one because red is a warm color and it's closer to yellow than blue in the light spectrum. The purple lab setup will produce the least oxygen and in the slowest rate because purple is furthest away from yellow in the light spectrum and it's a cool color. The green setup will produce more oxygen and at the fastest rate than the blue lab setup because green is closest to yellow in the light spectrum. So here are my possible errors. The first one is accurately noting the oxygen production and change in humidity even though we tested that. Okay, so for my experimental setup, these are the materials that I used. First one is the lamp, an LED light, a black box, a volumetric tube, a timer, a camera, a plastic container, and a humidity meter. So this is the measuring device that we suggest as an experimental method to measure the oxygen production that the green light has. The way that this machine operates is that a volumetric tube is inverted in a container with the colored water. The air is removed from the tube and the water rises inside it. Another airtight container is prepared with a plant inside it that connects to the volumetric tube via a pipe. The plant container is placed in a box so the sunlight can reach it. An LED light is placed next to the plant inside the box. As you can see in the picture, the box here is open, but the experimental procedure, this box is closed, so the sunlight cannot enter the box. When the plant produces oxygen, it passes through the pipe and flows into the volumetric tube, displacing the water inside it. When the water drops, we can measure the oxygen quantity in millimeters. So for my experiments, I tested each light for 1 hour and we conducted each experiment 5 times. For my first experiment, I used a yellow LED light. It produced 60 millimeters of oxygen in 60 minutes. This is a graph that shows the oxygen production of the yellow LED light in 1 hour. As you can see, I have error bars. I don't know if they're visible enough. And the time is in the y-axis because the errors that we found were in the time, and this is why we put the time in the y-axis, even though typically it's put on the x-axis. So for my second experiment, I used the blue LED light and it produced 20 millimeters of oxygen in 60 minutes. This is a graph that shows the oxygen production of the blue light in 1 hour, obviously in millimeters. For my third experiment, I used an red LED light and it produced 30 millimeters of oxygen in 1 hour. This is a graph that shows the oxygen production of the red LED light in 1 hour. So for my last 2 experiments, I used a green LED light and a purple one. The first one produced 25 millimeters of oxygen in 60 minutes, and the second one produced 15 millimeters of oxygen in 60 minutes. This is a graph that shows the oxygen production of the green light in 1 hour. And this is a graph that shows the oxygen production of the purple light in 1 hour. This is a graph that compares the oxygen production that each light had. Okay, so for my conclusions, the yellow light produced the most oxygen and at the fastest rate. The purple light produced the least oxygen and at the slowest rate. And the closer the lamp color to the sunlight in the light spectrum, the larger the oxygen production and the faster the rate of production, and this is why the first statement is concluded. Between 2 colors that are approximately the same distance from yellow in the spectrum, the warm color will lead to a production of a larger amount of oxygen production. This is a table of data that shows which color produced the most oxygen in decreasing order. So as you can see, all of my hypotheses were confirmed. The first one was confirmed because the yellow did have the fastest rate oxygen production and the largest amount of oxygen. The second one was confirmed because the red lamp setup did produce more oxygen than the green one. The third one is confirmed because the red lamp experiment did produce more oxygen than the blue lamp one. The fourth one is confirmed because the purple lamp setup did produce the least oxygen and at the slowest rate. And the last one is confirmed because the green setup did produce more oxygen and at the fastest rate than the blue lamp setup. Here are some references that I used for my experimental procedure and for my theoretical slides. And thank you very much for your attention.
thank you for your presentation. It was really nice. However, I would like some questions to ask you. So first off, what was the light source in accordance to the black box in which you placed the plant?
Can you repeat that question? I did not hear you.
Yeah, so where was the light box in accordance, the light source in accordance to the black box in which you placed the plant?
Do you mean what's the importance of the light placed in the box?
No, I mean the distance.
Oh, the distance. Okay, so the distance was a parameter that we kept controlled so that that would not have an effect on the experimental procedure. And we put that so closely so that we could close the box and the sunlight could not reach the plant. So the plant would photosynthesize only with the LED light. So
okay, thank you.
So the outcome would be only because of the LED light.
Thank you. So did you use any different light intensities during the experimental procedure?
Can you repeat it?
Different light intensities using the light bulbs in which you use in the experimental procedure. Did you use different light intensities?
No, because the lamp was always the same. So this is why the light intensity was always the same and it was a control parameter.
Okay, thank you. When were the experiments conducted? Were they conducted in a dark environment or a light environment?
They were conducted in our laboratory.
In a
laboratory.
And what was the light condition in the laboratory?
Okay, the light conditions in the laboratory could not affect the experiment because the box was closed, so the plant photosynthesized with an LED light only. So the sunlight and the light conditions did not affect the experiment.
And what was the temperature, the environmental temperature in the lab in which you
the temperature, I don't remember the exact number, but the temperature was always the same. Because can you go in my appendix? Thank you very much. Because the temperature was always tested and was controlled with this exact sensor.
Okay, thank you. How many times did you conduct the experiment? Was it only once, twice? Or...
I mentioned that in my presentation. I conducted each experiment 5 times.
Okay, thank you. Do you think that if you were to decrease the lightness in the lab in which you conduct the experiment, would this produce any deviations in the results you presented?
Obviously, the light intensity is a parameter that could change the outcome of the experiment, and this is why we kept it controlled, and we always had the same light intensity, because obviously that would affect the outcome of our experiment.
And did you observe the oxygen, the bubbles of the oxygen in which the plant produced?
I'm sorry?
The bubbles of the oxygen. Did you observe the bubbles of the oxygen in which the plant produced?
The oxygen was always the same in the box, if this is what you're asking me.
Yeah, so the production rate of the oxygen.
Time's up. Thank you very much. So they have 3 minutes to prepare a PowerPoint with all the pros and cons of this report.
Hello dear teams, my name is Mario Savidis and I'm going to be the opponent for the 11th problem called oxygen from plants. So the outline of the presentation was quite good, and as we can see here, the introduction of the phenomenon, the setup and the deductions were average, the theoretical explanation, the data analysis and the experiment were good to excellent. So concerning the theory, the strengths were that she had an excellent definition of the phenomenon, the photosynthesis and the wavelengths that the sun produces. There were enough factors and enough definitions. It was a well-structured presentation. They included visual data which helped our understanding of the phenomenon, and she had sufficient theoretical support which justified the results. However, some of the weaknesses that there was too much text in some parts of the presentation, and it was also confusing as she was rushing off the slides. So concerning the experimental procedure and their connection to the experiments, the strengths were that she had a good experimental design and process. She conducted the experiments quite well. She explained well the procedure and it could be reproduced by anyone. She had an excellent control of the variables and the constants. She produced interesting conclusions that verified the hypothesis and confirmed the theory, and she had a slide where she mentioned the evaluation of the errors and she explained them quite well. However, the experiments were conducted in a non-controlled environment in which the temperature wasn't tested, and there was also too much text in some parts which made the experimental procedure quite confusing. She was speaking too fast, which made the presentation confusing, and she focused only on the color of the light and not on the intensity of the light. So here are some missing points and the discussion which will be discussed later on. So so we can see the time of the day, the environmental conditions, the place at which the leaves were facing the light, the way that the co-oxygen was produced, light intensity, and the existence of the thermometer. Thank you for your attention.
Can I say some things before you start with the questions? Okay, so you mentioned that the environmental conditions were not controlled, but I told you that they were with an Arduino sensor, and the humidity was controlled with a humidity meter that was in the picture. And I did not test on other parameters because the task there was to suggest an experimental method to measure the oxygen production. So the experiment had to show that the method that we suggested was reliable.
Yeah, so don't you think that if you change the light intensity...
The light intensity was always the same because we used the same lamp, so I told you that we kept the light intensity controlled.
Okay. So how did you take the areas that have chlorophyll and thus they...
How did I, what? I'm sorry, repeat the question?
Yeah. So how did you take the areas of the plant you used that have chlorophyll and thus they can photosynthesize? How did you take these areas specifically?
I'm sorry, but I did not understand what you're asking me.
Yeah, so some plants, some parts of the plant we use only photosynthesize. How did you take only these parts of the plant?
I always use the same plant if that's what you're asking me, so that was also a control parameter.
Okay, thank you. Okay. So where did you play? So did you try and change?
And we used the whole plant, if this is what you're asking me, so this is why we took all of the parts into consideration.
Yeah, so you're telling me that the whole part of the plant produces chlorophyll, the whole plant?
Yes, we used the whole plant, so the result of our experiment was about the whole plant.
Okay. Did you try and change the position of the light in accordance to the plant? So did you change and place it around the plant?
No, we kept that controlled in my parameters because the lamp distance would affect the result of our experiment. So we put the lamp in the same position in every experiment.
Okay, and what do you think would happen if you were to change and place the light around the plant?
Okay.
Would that produce any deviation in the results?
Obviously, the farthest away the lamp would be from the plant, the less the plant would photosynthesize. And the reason why we kept it so close, as I told you in the questions before, we put it so close so that we could close the box, and the plant would only photosynthesize with an LED light, the light that we used.
Okay. Did you check the production rate of the oxygen? You said that, I think you mentioned in your presentation that you checked for 1 hour the plant, how much oxygen it had produced?
Yes.
What was the production rate of the oxygen?
The production rate?
Yes.
I put it on my graphs. I think, what do you mean the production rate?
Okay.
We represent the production rate by the oxygen produced by the photosynthesis, by the process of photosynthesis.
Thank you. So, what time of the day did you conduct the experiment?
Yes.
Yes. I'm sorry. What was the time of the day in which you conducted the experiment?
Okay, so in order for us to have a reliable result, we tested that experiment 3 days in a row, and each day got us like 10 hours a day so that we would have a reliable result. But the time of the day doesn't matter anyways. But it was always the same. So even if it did matter, that it doesn't, even if it did matter, it would not change the outcome of our experimental procedure because it was always the same.
Were the shutters closed in the lab in which you conducted the experiment?
I'm sorry?
The shutters. So in which were
sunlight.
No, the shutters in the windows. Were they closed?
What exactly are you asking me? I'm sorry, but I cannot hear you.
If you cover the windows, the light that was coming in through the windows.
Okay, I explained you before that whether having lights in the room or not did not affect the experimental procedure because the box was closed. So even if the room was full of light, that would not change the outcome.
I believe that the time of the day
plant photosynthesized only with an LED light.
I believe that the time of the day you conducted the experiment does matter because whether light comes in or out does produce certain deviation to the results.
Obviously, the results would change if light got in the box. So if the box had...
Time is up. Thank you. Stay.
So I have to ask the reporter, did you use only one kind of lamp?
Are you asking me if I used a different type of lamp?
Yes, yes.
I said in my presentation that the type of lamp was always the same, and this is why the light intensity was always the same. So yes, the LED light was always the same.
Do you think you should have tested more?
I don't think so, because then the light intensity would be different, and so we had to add on in our parameters. And this is a parameter that we kept controlled, so that the results could be more reliable and more accurate.
You said that all the experiments were in the same place conducted.
Where?
You said that all the experiments were conducted in the same place, right?
Yes.
But they were not, the environment was not controlled.
It was, because we tested the temperature with an Arduino sensor that I showed in my appendix, and we tested the humidity with a humidity meter that was in the box.
I have to question you. Why do you think the distance would make any difference?
The temperature.
The distance from the light to the plant.
I'm sorry, I can...
You said that the distance would make difference. What difference exactly it would make?
So as far away as the lamp goes from the flask in which she placed the plant, then the light wouldn't be as intense as it would be if the light was placed right in front of the flask. And thus, the photosynthesis wouldn't be so the oxygen wouldn't be as much.
You didn't test why would... Okay, I have to ask another question. You didn't use sunlight, right?
I did not use sunlight. I used the yellow LED light that is closest to the sunlight.
Okay.
So, yeah. I said that no sunlight could enter the box.
Okay. That's all I have to ask.
Thank you.
Reviewer, you have 3 minutes for your review.
Hello, my name is Varadol, and today I will be the reviewer of this fight. So here is the problem. I feel we are all familiar with it. Problem 12, sorry. General outline for the reporter. Introduction was well structured, and the theory was pretty nice. There were a lot of pictures, which was really nice too. But I have to say, for the experiment, it was lacking parameters, and the experiment environment was not controlled at certain parameters. And the conclusion mentioned possible errors and made an evaluation. For the reporter, the pros had useful details and good definitions. The presentation was well structured, and the theory was explained with photos and graphs. The answers were based on the theory, and had a very good use of the time. Had a very great eye contact and good body language. Now for the cons, she could have tested in more than one plant. I feel that should be better. And she was talking too fast for us during the presentation, and should have used other parameters too. For the opponent, I have to say the pros, the notices were very logical. The questions were very relevant, and they spotted the lack of context. The presentation was very structured and put great pressure on the reporter. And for the cons, he questioned some data that was already mentioned, and I didn't feel like he stated his opinion He could just done more for that and did not cover the time limit. Now for this discussion, the points for the opponent were made and they were pretty nice. The reporter answered them through their theory and was very confident about them. Some relevant questions were made though, but I feel that this is okay. Now for the reporter, some suggestions that I have to make. I should have introduced some parts of the problem better for us to understand it more clearly. She could have tested more than one plant, as I already said. And the parameters such as the different type of water and sunlight, which already was covered in the discussion. The opponent should have better time control. I feel like there were many minutes left, and should have pressured the reporter a little bit more so could get more interesting in the discussion. Now for the summary of the fight, I have to say I was pretty impressed with both, and I really liked both presentations, well structured. I don't have many things to say, I was impressed of both. This is it. Thank you.
We believe that the reporter made an interesting presentation. However, she only focused on one parameter. Parameters like the type and the shape of the plants were missed, while she did not measure constantly the temperature with a thermometer, which highly affects experiments since enzymes are easily affected by the temperature. Also, the time of the day highly affects the result, and she mentioned that it was kept stable. We have she also could have changed the distance between the lamp and the black box in which she placed the plant to test like other parameters. As for the reviewer, we thank her for her suggestions, and we will certainly try to incorporate them in our next presentations. Thank you.
First of all, I want to congratulate both the reviewer and the opponent for this amazing stage. And I want to say that because it was mentioned both by the reviewer and the opponent multiple times, I said many times that all the environmental conditions were controlled with an artificial sensor and a humidity meter. Also, the room light and the sunlight did not affect the results because the box was closed and the lamp was inside it. So the time of the day did not matter. Furthermore, the problem statement asked us to suggest an experimental method to count oxygen production, and this is exactly what we did, and this is why we did not test more parameters, because we want to make sure that the experimental method that we suggested was reliable and the results were accurate. Thank you very much for your attention.
Okay. I have some questions for the reporter. Okay, the temperature is a crucial factor for this experiment. You have mentioned that you used a temperature sensor.
Yes, an artificial sensor, yes.
Can you tell me where did you place that sensor?
Yes, we placed that in the table that we also made our experimental procedure, so that not only we would test the temperature in the room, but we would also test the temperature that could affect our experiment, so that it would be more accurate.
So not inside the vessel that you use for the process?
We wanted to test...
in the water?
We wanted to test the environmental temperature of the room because we wanted to see how that would affect our plant, and we wanted to control that. And we had a thermometer inside of the box. I don't know if it was visible.
Inside the vessel with the plant, you mean? Inside the vessel?
Yes, inside the airtight container that had the plant in it. I don't know if it was visible enough in the pictures, but we had a thermometer in it.
So you record the temperature during the whole process, all the time?
Yes, we tested both the environmental and the plants.
Okay. Another question for you is, did you check if your results are in agreement with the literature?
With the?
Did you check if your results are in agreement with literature? I mean the comparison between colors of light and the volume of oxygen produced.
Do you mean if they agreed with the theory that we found?
Not the theory, the literature, the references, the
Oh,
bibliography.
yes,
Did you check
they were actually, yes, we compared them and they were accurate, and it was basically the result that we somehow predicted them to be.
Okay, and in your hypothesis, I think you have mentioned that you are going to check other plants. Am I right? Or
In my hypothesis.
yes,
No. In my hypothesis, I did not
Okay,
mention
so that
anything
was a controlled variable. Okay, thank
Yes.
you.
Okay, I will start with the reporter. I see that at the graphics you had a different gradient.
A different?
Gradient.
Yes.
At the graphics. You have-
Oh, yes. Yes.
Did you explain why this happened?
Yes, of course. This was because of the error bars that we found and because of the different LED lights that we use, meaning the different colors that were put in the box.
But in the same color, in the yellow or the red,
Yes.
we can see different gradient.
Oh, in the comparison, okay. This was because the numbers were different, so that we could fit all of them together. This is why they were different. The slopes. This is why the slopes were different because the numbers in the axis.
Please slower so I can understand.
I'm sorry. They were different. The slopes were different because the numbers in the axis, in the y-axis and the x-axis, were different, so that we could include every single light.
Thank you. And for the opponent, in which way do you think that the sunlight or the time of the day will affect the result when they explained that the box was closed? In which way do you think that the sunlight or the time of the day will affect the result? Because the reporter said that the box was closed during the experiment.
Now, I think that we would have to, the sunlight does affect the temperature at which the experiment was conducted, because in order to have the most accurate results, we would have to be in the darkest possible area, so that the lamp that was placed in order to have the plant photosynthesize would have to be the only light source in the room.
So you think that the closed box is not dark enough?
I think that the light would have a slight deviation in the results.
Thank you.
Thank you very much. Time is up. Thank you. You may-
Bye, guys.